Welcome to this week's Swarf and Chips. This is what's coming up on today's show, and don't forget to subscribe to the channel by clicking on the button below. Now, joining us on the sofa is a company that have got a huge social following. We're joined by Mark and Stuart from Autodesk. Welcome to Swarf and Chips.
Thanks for the invite.
It's great to be here.
It's a pleasure. So Autodesk, many people watching may already know who you are, many people may not. So who are you, what do you do?
So Autodesk are a software development company. We're headquartered in San Rafael in California. And obviously, by my accent, you can tell I'm based in the UK. So we have facilities all around the world, one of them being in Birmingham. And we help companies imagine, design, and create their products.
But you also were known by another name to many people in this industry, which is CADCAM.
Absolutely, yeah. So myself and Stuart, we're part of the original acquisition of CADCAM by Autodesk in 2014. So we've had 4 glorious years of getting integrated and helping our customers transition into a much bigger portfolio of products to help them make anything.
So how has that transition gone?
Fantastic. I mean, for the first 2 years of the acquisition, we worked as a wholly owned subsidiary of Autodesk. And for the last sort of year and a half, 2 years, we've been integrating, adding more technology, changing our pricing and packaging to make it even easier for our customers to access all of the technology that Autodesk has to offer.
So from a CADCAM client's perspective, it's better for them as well, not just for the legacy Autodesk clients?
Well, absolutely, because our customer base are kind of traditionally been in the sort of CNC subtractive manufacturing world, and now we can bring to bear some of the technology with additive, with composites manufacturing, with nesting capabilities, and with simulation. So the portfolio is a lot broader than it was under CADCAM, and the organisation as a whole is 8,000 people worldwide, serving over 12 million customers. So it's a fantastic relationship to share that with our customers.
It's definitely a benefit there. And you're based in Birmingham, aren't you?
Yes.
So what have you got based in there to help people almost see and bring the software alive?
So obviously we've got a lot of our development and sales organisation based in Birmingham, but one of the real key things that we have there is our advanced manufacturing facility. And this really is our sort of industry 4.0 proof point for a lot of our customers, a factory of the future, if you will, which allows customers to come in, see the technology they can use today, but also start to understand how they can implement new technologies and processes in the future, which will benefit them moving forward.
Wasn't there a launch that you went to?
Yeah, I went to the launch. Incredible. Come out fully inspired, I'll be honest with you. It's astonishing that the size of the place, the technology on show. Like you've mentioned, IoT, Internet of Things, Industry 4. We hear it every week now, every day probably. But it's very rare you actually get it, you actually see it. It's not tangible currently. You go to Autodesk, you actually see it.
Yeah.
And what's this FoMT?
It's the future of making things.
This was something that was mentioned a lot at the launch, so...
It was, yeah. I mean, the short version is it's a process that enables our customers to increase their competitiveness and their productivity. So if you look at those two fields of competitiveness and productivity, they're very broad subjects with many external influences that can affect the outcome if you try to measure these or improve their effectiveness within your business. So Autodesk have realised that the only true way you can do this is by looking at the processes for the whole of a life cycle for a product or products within that business.
Right, okay. Can you expand a little bit more on that? How are you doing that?
So what you have to do is you have to start right at the beginning, and this will be with the concept design of a product, and then monitor it through its design processes, where eventually you'll get to the end design, which is released into manufacturing, where the part is then made and put out into the marketplace to be used by the consumers. Now this can have and create a design loop where we take feedback from the marketplace, put it back into design and feed it back through to the next iteration of product that will be in the marketplace. And in the modern world, this can happen many times before a product is eventually retired and taken out of the market, which is quite a large time frame. So during that time frame, the company needs to keep on top of kind of the mainstream design and manufacturing processes, but at the same time be in touch and hand in hand with the emerging technologies that are coming out into the marketplace.
Yeah, it's got to be an advantage. In days gone by, you'd speak to one company about a design software, and then you'd have to get it manufactured elsewhere, the software. Whereas now, obviously, you do everything from concept straight through to manufacturing design, not just subtractive, but additive as well.
You've got to deal with the different trends that are happening in the market too.
That's correct. There's so many different processes and technologies, and from when you start a project, new processes and technologies can come into the marketplace. And that is really what the future of making things is about. It's enabling our customers to manage, adapt and evolve those processes through their product life cycles.
I guess fixing problems you don't actually know you've got.
Yeah,
Absolutely.
Exactly.
true. Actually, saving time and money ultimately.
I mean, one of the key things we're also seeing as a bit of a trend is the convergence between design and manufacturing. So, like no time before, we're seeing the actual design itself being influenced by the manufacturing process. And we've got some examples that you can see, on the screen here. So this is a typically machined part. It's probably done in multi-stages to actually machine it all away, but it's actually quite heavy. And this is a steering upright. So the heavier the vehicle is, the more power it needs and the slower it will go. So we need to be able to light that in certain ways. So we're able to take some of the manufacturing process up front and actually redesign or re-engineer the part so it's structurally sound, it will work and it's fit for purpose, but it's actually more lightweight. It can actually make the car perform faster. So we've got another example here, for example, where we've actually 3D printed the part. So this is actually using a lattice work, as you can see in here. It's reduced a lot of the weight from the actual component itself, but it's still got the same strength and residual structural strength that you need to perform in the performance vehicle that it's actually used in.
People have got to be a bit sceptical though, all this change happening, additive and, what is it, high-end, high-feed deposition or something, but people have got to be a little bit sceptical about new things. Do you find that, what do you do to overcome that?
Well, it's very similar to back in the day when 5-axis machines were started to come out onto the market. There was a lot of skepticism about implementing that technology, and also the cost to access it was quite extensive or quite expensive. And so in the same way, we're starting to find new, more sweet spots for using this advanced technology, which can be approved in a production run itself. So we've just had the first 3D printed propeller that's been accredited and used and in use today. Yeah, it's part of the RAM Lab project. And aerospace, of course, are using these new technologies to actually build large monolithic structures as well. And so they'll go through the same accreditation process. It will take some time, but you'll see more and more these emerging technologies start to complement and in some instances actually overtake some of the traditional processes.
So have you got a facility then that enables people to be able to test what you're talking about?
Yeah, absolutely. So if you come to the advanced manufacturing facility that we have in Birmingham, we're one of 6 around the world, by the way. We all have certain strengths in what we actually provide within Autodesk. But the facility in Birmingham itself will allow you to come and have a look at subtractive machines. We've got Mazaks, multi-turning machines.
Yes, you've got the robotics, you've got cookers as well, you've got absolutely loads.
Yeah.
If we just go on the commercial side, since the acquisition of CADCAM into the Autodesk brand, there's been this subscription model, hasn't there? There's been a change in how you go to market with your products. How have you found that?
Well, the consumer world is kind of changing all the time, and the way that people want to access their products and services is changing as well. I mean, classic examples of that are things like the way people access media and music and television programs and so forth. And we're actually starting to see that come into industry as well, as more and more businesses want to diversify into new markets. So having access to the correct technology for specific projects or for certain periods of time is becoming more and more common. Subscription model has a lower upfront cost or entry cost point of use. So this enables customers to be able to do that. So if their workflow increases, they can very easily expand their software capabilities. Or if things ebb away and they move into another area, they can easily decline their usage.
But I take your point, and as a business, we subscribe to various software, so we get it. But there must be engineers out there that don't like it. There must be.
I think there's obviously going to be barriers to accepting this technology moving forward, but actually the uptake has been fantastic, and obviously we've been implementing subscription-based technology through our manufacturing base for the last year. And it's been well received. I think it will take time, a bit like using new technology, a new business model.
Well, like I said, people can be quite sceptical and not be, it's a bit the unknown, isn't it?
Yeah.
It's a fear of the unknown.
But ultimately, what Autodesk want to do in this process is we want to be able to bring new technology to market faster. We've got one business model that allows companies to have a lower cost of entry to try these new technologies out. It means that we can continue to develop the technology they need at a faster rate than the competition are able to access it through some other
How
means.
about software updates, the training, things like this?
So it's very similar to the old days under CADCAM from that perspective. So we've got all the same training facilities and the online material that are there to support our customers in order to make use of this technology.
And I guess the beauty is, if your business grows, you phone up Autodesk, or you probably do it online nowadays, you get a new subscription. Equally, if work dies off and you have to let people go, unfortunately,
You're not wasting money, aren't you?
You're not spending maybe 20,000-30,000 on a suite of software where you can just untick a box essentially.
And I mean, apart from that business aspect of it, it also allows us to connect with a subscription, our technology, via the cloud, so we can use more collaborative tools. So we've got some great examples already with the current releases where we're able to share views. So no matter if I'm a user inside of PowerMill, for example, I can actually see that technology, work with my supplier and make sure, is this what you wanted to machine? Is this the right way to go about it? So there's much more interaction with the supply chain, and having that additional information, I think, is definitely going to benefit our customers moving forward.
We'll come back to you in just a moment, because we are going to head over to Technical Corner and ask you some more questions about how your company can manage a company's production. But Gio is over in Technical Corner with Robin, and we talk about the future of making things, but I want to know about how Autodesk can help your company now.
Technical Corner.
Robin, welcome to Technical Corner.
Thank you.
We've heard a lot about Autodesk's vision for the future and the technology that you have available, but what technology do you have available today?
Sure. So for PowerMill 2019, we've really developed three key strands of activity. The first is to enhance existing functionality. The second is really to leverage the wider Autodesk organisation. And the third is to innovate, is to look for new ideas.
We've obviously got a brief of the things that we're going to discuss today in Technical Corner. The first one I'd like to touch on is the PowerMill additive. Can you tell us about that?
Yeah, sure. So PowerMill additive, I mean, we're seeing more and more machines that are out there these days that are both additive and subtractive, hybrid, if you will. And what we've done is really with PowerMill is provide a one-stop shop for programming those machines. So you're able to both do the subtractive as you normally would, but now look to build the parts using additive technology.
And how popular is this market becoming?
It's rapidly growing, forgive the pun. It's becoming more and more popular because people are starting to realise it's not just a dream that people are talking about. There are actually some really useful applications for this.
Is this changing the way that components are also being designed and people started to think out the box really now?
Yeah, absolutely. I mean, if you think of a traditional part, subtractively you get down to the final shape. What about if you were able to subtractively take part of it down, but then add parts on that maybe you wouldn't traditionally be able to machine in a subtractive way, and then use subtractive to get the finishing quality that you want. So you can really think about manufacturing in a completely different way with this technology.
So let's talk about the next piece I have here, 5-axis collision avoidance. This is going to be far more mainstream, isn't it?
Sure, I mean, it's technology we've had for some time now within Autodesk. But what we've really done here is look to enhance the experience for our users. So traditionally the user would have chosen the right collision avoidance strategy in order that the tool would not collide with the holder or the shank in machining. Now what they simply do is choose the automatic option, and PowerMill detects what type of strategy they're using and then uses the most appropriate collision avoidance strategy to ensure that the tool doesn't collide or the holder doesn't collide in the process of machining.
So it's simplifying the process effectively and making it easier for the consumer, the customer, to program a 5th-axis machine, especially if they've just bought an expensive 5th-axis machine. The last thing that they want to do is to have a bump.
Absolutely. We want programming 5-axis to be as simple as programming 3-axis, and this technology really allows that because the user doesn't have to worry about it. We deal with all of this, and we deal with those potential collisions and move away from those safely for them.
And there's two areas of this though, isn't there, from reading in it a bit more detail? There's the one before the machining, or before the machine, and then one after?
Yeah, that's a good question, because quite often our users don't know. They might have a shop floor full of lots of different machines. They don't necessarily know at this stage which machine it's going to. So at the first level, as you calculate the toolpath, PowerMill can calculate and make sure that not only the tool and the shank and the holder, all of those three, are safe and don't collide. And then at the second level, when they know which machine they're going to, we can employ the next level, which is to really test the kinematics of the machine for not only collisions, but also for axis limits, so that they know that what they're sending will work first time.
Because you've used 5-axis machines in the past, and it can be a scary prospect, can't it, certainly for new users?
Yeah.
So this is a good way of getting you into it.
Yeah, can you set parameters, like safety parameters with this?
Yeah,
software?
I mean, it's a great question, because what we use is kind of everybody's familiar with traffic lights, right? So we use a traffic light system. We've got red, don't send, there's an issue. No comment. Yellow, which means you haven't tested it, and green, which you can automatically set to happen, and that means that you have tested it. And if you've got to the green level, you've tested everything. You've not only tested everything about the holder, but you've also tested the machine as well, so you can relax and enjoy.
Often with this type of software, manufacturers state percentages of guarantees that there's going to be no collision. It might be 97%, 98%, but are we saying with the green light that is...
What we're saying effectively is that everything that we're sending out has been tested from our end. Of course, we can't factor in things that happen, maybe holders or fixturing that wasn't on the machine when you simulated and so on. But yeah, what we're saying is that as we go through here, we're giving it a full test from start to finish.
Green is good to go. Let's move on to Vortex, okay? Because this is, again, this is a roughing machining cycle, correct?
Yeah, it is, exactly, yeah. Vortex is an interesting point. I mentioned earlier on that we've got the three key strands. And the Vortex really falls into that middle strand, which is about leverage. And what really I mean by that is we've looked across what is a very big sweet shop of technology at Autodesk. We've got a big sweet shop there. And we've seen sweeties, if you like, that are inside other products that we really quite like the look of for PowerMill. And the adaptive area clearance technology we've acquired from other parts of Autodesk is a great example of that. And we've moved that across. We've called it Vortex for stock within PowerMill, so it's a subset of the Vortex code for hard metal cutting that we already had. Now the interesting point is that on many occasions, in many situations that we've tested it, we're finding increases in time saving of 30% or more with it, so it's exciting.
How can you kind of illustrate how you're saving 30%? How are you achieving this?
Yeah, so to get into a little bit of how it does it, the way that the traditional Vortex code, which let's get this right, is really efficient anyway, the way it works is to take offsets of the part and offset those outwards. Of course it would machine inwards, but the calculation is done almost like ripples in a pond moving out. The difference with the Vortex for stock code is that it uses not only the offset of the part, but the offset of the stock shape. And it uses a combination of those to go around. And what that really culminates in is much less air time, and that's really where the saving is.
Because often with strategies, companies say that you need to have a specific machine or a specific tool holder or cutting tool. That's not the case with this. And when you say you're 30% saving, are you just saying you're comparing like for like?
That's exactly right, Paul. Yeah, we really are testing. Here is what it is. These are the parameters, the settings, the tools, the fixturing using the traditional Vortex code. And here are the parameters, the exact same parameters using the new Vortex code, and the saving is 30% or more in many cases.
And what machine is this? What machine does it lend itself to? 3-axis, 5-axis, horizontal, or machining?
Specifically 3+2 machining. So it's about area clearance. It's about getting down to that shape that you need to get to as quickly and as efficiently as possible.
Because you did mention hard metals as well. So if we were talking about aluminiums, is it achievable? Those kind of results?
Yeah. So for the appropriate tooling, so maybe a solid carbide tooling, it's a great strategy. We're rather than using big step overs and small step downs, which is the traditional way of doing things, it's big step downs and small step overs.
So to summarise on the Vortex, who's that for? Who's going to be looking to purchase that?
Any of our customers that are looking to gain productivity, gain efficiency, want to remove hard material quicker, and ultimately get their parts out to their customers.
Okay, moving on again then. Final point here, fusion. This is a very interesting one for me because when we look at this type of software, this actually lends itself or fits perfectly in with your other products, doesn't it? Can you explain what it is?
Yeah, I mean that's a great question, because one of the new products for us is Autodesk Fusion Production. And if I was to really simplify, boil down what Fusion Production is, it's a tool to help us to get from that NC code being created through to the part going out the door as quickly and as efficiently as possible. And so what we've done with Panel 2019 is we've created a direct interface into this new Fusion Production tool so that our users can effectively package and deploy the job they're working on, whether that be NC code, setup sheets, images they need, and send that on its way through the Fusion Production journey. Now, the interesting thing about Fusion Production is it's cloud-based, so people within the wider organisation of our customers can access that via a web browser or a mobile phone to see exactly where the jobs are and where the inefficiencies might be in the process.
So effectively, is this data collection like Industry 4 to do with Industry 4?
It's all over that. I mean, it's all about, you know, working smarter, not harder. This is about being able to get the most out of your productivity in your shop floor so that you can reduce those cycle times.
Sorry, Paul. With your software, effectively, are you synchronising all of the technologies that you have available to you?
Absolutely.
And using the leverage that you mentioned
That's
before?
the plan. We have all these tools. Let's use them. Let's use them to our advantage.
Because with the Fusion as well, I also thought maybe taking it one step further, you could give your customer access to see progress on jobs and things like that. Is that possible?
Yeah, that's potential. I mean, I guess that's a choice of our individual users, but that's possible. It can be opened out, and again, that's on an individual basis.
So when we look at the products that we've discussed here, it's quite a nice fit. All of them fit together quite well. Often you might have to go to a third party to buy an equivalent to Fusion, let's say if there is one, or even verification software for anti-collision. But here we're saying the whole lot can be supplied by yourselves.
Absolutely, yeah. No matter, we're working hard in future areas as well. So, we want Autodesk to be the place to go when you need something solving.
Excellent. Back to the studio. Thank you a lot.
Thank you. Now, Robin mentioned Fusion Production. Can you expand on that more about the management of a factory?
This is great actually, because it kind of shows how the company's evolving and how we're going to bring more technology to our customers. So we've focused around developing expert tools to get the most efficient way to produce a part on a CNC machine tool or on a robot. But a lot of these components are actually using multiple devices in a factory, and to be able to manage that production scheduling, to look at the raw material, how it comes through the process, and also look at the machine utilization you're using. We've developed a product called Fusion Production to manage just that. So this enables us to kind of move from beyond just getting the most optimized way to use your machine to the most optimized way that we can actually run your factory.
And running the business, yes.
Good,
because sometimes people, and I'm sure we've said this before, but people will become an engineer, but then they're ending up managing the whole company, and they need a little bit of help with that. So.
No, it's really exciting and it really complements the technology well. So we've already launched that particular product in the Americas, and we're going to be bringing that to the UK soon. So we're looking for some new test sites to actually give us some more feedback about how this is going to work. So this is a great opportunity to kind of make people aware of it, and then hopefully they can find out more on our website.
Yeah,
absolutely. Where do they find out more about the future of making things?
Well, definitely come to the website. So www.autodesk.com/make.
Yeah.
As we discussed earlier, if you would like to come down to the advanced manufacturing facility in Birmingham, please do so. You can see
do that for sure.
Yeah.
Do that.
Yeah. I think that's really, really important, because I think that's the moment where I think you will say, this is who we are, and people will get you.
Yeah, it's more tangible. They can see what we do. They can understand how it can help their business moving forward. And
other than that, they can come and see us at the MAC show next month in April, Hall 17, stand 600, where we'll be showing all of this technology.
Can't wait, and we'll hopefully see how Autodesk can help you make anything.
Brilliant. Well, thank you so much for today. And I think, people who are watching may hopefully have learnt a little bit more, and encourage you yourself to get to meet you and see what you're all about as well. And any old CADCAM customers, maybe go onto your stand and talk you can help everyone, historically as well as new customers. Now, we want to thank you for coming on to the show. So, where are the bags, Joe?
We've not bought them, never mind.
But I can help you with that one, because I know you're always giving gifts out to everybody else, but we thought we would give you guys a bit of a gift, so we're going to turn it around a little bit. So here's a little goodie bag for yourselves.
Oh, look at this.
There you go.
Joe, I feel guilty.
Wow.
Oh my goodness. I'm going to have a look at all of this. This is so kind of you. Thank you so much.
I made it all myself.
Oh, yeah. Well, we really look forward
Any
to...
chocolate?
No, we ate all the chocolate on the way in, I'm afraid.
Wow.
Food again.
USB sticks.
Are we
wow,
allowed
look at
to
this.
actually open all of this out whilst we're on set?
So are we still rolling?
Yeah, we are still rolling. Right, let's finish
Oh,
the show.
power
Thank
bank,
you,
power bank.
Stop it. Thank you so
love
much.
Fred.
We look forward to seeing you both at MAC in just a few weeks' time. So thank you for
Fantastic.
joining
Thanks
us
for
on the
coming
show.
on,
having
guys.
us.
Appreciate your time.
It's been
Thank you.
great. Thanks.
Cycle Time Challenge.
We're here with Clinton at Autodesk. Clinton, what part have we here?
So I have in my hand an aluminium part that's been designed using Autodesk's generative design technology, specifically for CNC machining. It's been cut using Autodesk PowerMill CAM software on a DMG Evo 60 machine behind us.
So there you have it. Lyndsey, back to you in the studio. How long does this part take?
Thank you for watching this week's Swarf and Chips. Don't forget to like, comment and subscribe. If you want to watch any previous episodes, click on the links here. And as we always say, keep those spindles turning.